it struck my curiosity that in the recent years, its popularity has increased. Maybe in 2011, there were maybe 1-2 these games of this kind, but since 2014, the number of games has increased. Of course, the number of games in total in digital distribution platforms is not the same number of games that you can find in other very popular genres, just like RPGs or arcade games. But nevertheless, you can see a trend, that programming games are becoming kind of sexy. Lots of people are using this tag to identify some games. And in fact, well, for this paper, this study was up to 2019. But for this presentation, I updated the data, and this year, 38 more games were presented. And there are 32 more in development, meaning that the number of games right now which have been published this year or will be published next year are the same that all the number of games, if you add these graphs, together since 2011. So it's like increasing very quickly, this kind of games. So well, just some screenshots later. I find a little bit more. When I say about programming games, we can find games like AlgoBot, which you have to control as more robot, saying the instruction that you kind of logo, that you say you go straight, you turn left, right. One that I really enjoy is human resource machine, that you have to tell your avatar what he has or she has to do, using instructions. And there's also Heartbreak, which is a graphic adventure, but you have to create some programs to solve some puzzles. And then one of my favorites is this one, is Shenzhen, which you have to program microcontrollers and pass tests, generating some kind of signals. But for me, the most interesting part here is that these are games which were designed to have fun. These are not serious games or educational games. These are games that are sold next to other franchises, or just, such as Final Fantasy or Resident Evil. They are sold to people who want to have fun, and they have fun programming instead of defeating enemies. They are not, the creators did not develop these games to educate on programming. They created them so people can have fun, first and foremost. So for me, it was quite interesting, this increase in the number of programming games that have been developed to have fun, not to teach, just to have fun. So I wanted to ask myself, what are the main properties of these so-called programming games, from a game design standpoint? Then also a very relevant question for me was, it's very easy to say this game is a programming game, but are they really about programming as we understand it? Saying the process of preparing an instructional program for a device. It's because sometimes you see, okay, there's this computer metaphor, you are a bit inside of a computer having adventures, but is it really about programming? And finally say, okay, so if some of them are really about programming, let's sit down and see which kind of learning outcomes concepts could be considered to be covered in each game. So do they really have some educational edge? Could they be used to teach programming apart from having fun? So we performed this study on the Steam digital distribution platform, using mainly its API name is SameDB, which usually can allow you to identify games by tag and get all their properties instead of having to manually do everything. We concentrated only on games. If you look the programming tag, you will find that there's a lot of DLC. There are apps. There are some programs to create games, but not games themselves. And also sometimes they include games which are not really about programming, but since they have some modding tools, they kind of include the possibility to program. But we just look for games where the core experience were about programming. Of course, since we identified 70 different games with this tag, we could not play really a long time to each one. Just calculate the number of hours we would have to play to really finish all of them. So at least we played for 2 hours, and then we read like reviews or guides to have more insight about the content of the game. But sometimes we really enjoyed some game and we really play until we finish the video game and reach the end. And when we wanted to classify, categorize the curriculum categories, we based on this paper by Becker Fitzpatrick, which is from 2019, quite recent. I know that the ACM curriculum is very popular when in this kind of studies, but we wanted to use something that was more current, and was based on what is being actually used in different universities around the world. So to get a general idea, we could look at the programming games tag, which are the usual tags used in programming games. Of course, the main tag is programming, but we can find some interesting things. That programming games are usually also considered like puzzle or simulation games. As I said, they are quite niche, so they tend to be indie games, by small developers which want to create a very specific fan base. It's not for the mainstream public, They tend to be single players. And of course, even though they are programmed for fun, the education edge is not lost. Some of them are also classified as educative games. But nevertheless, something interesting also is that if you look at the word cloud, the game, the tag difficult is also quite often, is found quite often. Instead of easy or casual, most of them are considered difficult games. And when we played, we realized that the difficulty curve increases very quickly. They are not really easy games. They pose interesting puzzles, and sometimes some games would be labeled as casual, but they were kind of joke tags. Actually, this game was the most difficult of all, but people tag it as casual just to trick people. But they are even using this word tag. The word casual appears here. Some of them is false information. They are actually very difficult games. So in order to study these games, we propose a categorization, and we base this categorization in the coding interface, how the player is programming in this game. And we basically identified and proposed the different blocks with different subsections inside. On one hand, we had what we call the direct control, which are games where you directly with your keyboard or with your gamepad, you control your avatar and you have to do some actions. And in such a manner that basically the code, the program is in your brain and you are the CPU and you are executing. But there's really no automation. Everything is in real time. A bit more similar than that you actually type something. There are games where you control your avatar, not directly with the direction codes on gamepad, but using a command line. You introduce different commands which can be parameterized, but again is one by one. There is no list of commands that automatically execute. You do it in real time. Then it's maybe a bit more similar to the concept of programming. There's the category we define as processors, which we will see one example now, but it's kind of more, there's an input, there's an expected output, but it's more like hardware design. You have different blocks that you put on the screen, you interconnect, and they transform the input into an output, and you have to solve the transformation correctly. But it's more like hardware design, not exactly programming. Or sometimes you have to program a state graph, which it's basically you have the inputs and you modify the behavior of your avatar using a state graph. Again, there's no code, but depending, you have to process these inputs so your avatar will behave correctly. Which, in fact, it's usually for games where you have to program AI, which is the strategy of the state graphs is usually used in video games, in the code of video games, in order to program the AI of other characters apart from the player. But here, there's automation, but there's no code as we understand intuitively. And then finally, we find the kind of games which maybe we would really consider about programming, which are action blocks, like blocks which are graphical. Everything is just graphical, and you just really create a program and you say the set of instructions that the avatar will have to follow, and you have to think ahead Just you have to resolve this problem in 10 steps. You have to write 10 instructions, and the avatar will execute them one by one, and let's see if you solve the challenge. Then a little more advanced, we have code blocks. Instead of having pictures, you actually have letters, you have words. Some of them can be parameterized. You even can have some logical or mathematical operations here, but this is text. It's no longer just pictures. And finally, you have the games which have the real thing. No, it's text. You open a blank, something akin to a blank file, and you start writing with text, and you can react return, and you execute. And if you didn't write the command correctly, you have a syntax error. No, meanwhile in the blocks you cannot have a syntax error because everything is preset.
Okay, 5 more minutes.
Sí, okay. I will be well. These are just some examples. For instance, for the direct control, was one well-known name is Baba is you, but as you can see, you're not really programming. Of course, there's some computational thinking approach, some logical thinking, but there's no program here. So you have to just push everything around in order to find the solution to the rhythm. Regarding command line, well, another example would be Daskers, no, where you can see that you have to control different drones, but in order to provide give orders to them, you have to actually type, like in a MS-DOS command line instructions. No? If you want to redirect energy or detect things inside the room, no, you are investigating a derelict ship, and all controls are using this command console here. So there's kind of this computer aesthetics, but you are not really programming again. This is the example what I said about processors, no? That you have input, you have output, you even have tests, no? And there are some metaphors about you are processing memory, etc. But still there are no instructions, no? There are just processing blocks. This could be an example about the graph state. No? So you say you give you have to program different robots that have to fight, and you say, okay, depending on the stimulus, the input, are you detecting an enemy? Are you receiving enemy fire? What do? You evade? You don't? Here would be an example about the code blocks. No, you don't have really letters. No, but here, yes, you have a set different orders, different instructions that you have to order in order to process everything, no? And either you have different items interacting in real time, no, in parallel. The next one would be the code blocks. Again, the instructions are preset. There are code, you read them, but there are blocks that you just mix and match in order to give orders to your avatar, and then you execute, and he proceeds. And finally is the real thing, no? Like here you have in Hexapad, it's a small robot that you have to move, and you have to copy files because you are inside the CPU. And then, well, it's a bit smallish, but you can see, no, in the corner that you are actually writing code, some kind of assembly look-alike, and then you execute your code, and there can be syntax errors, and then you have to optimize in size or in speed. Another similar one, maybe this is one of the games that I most enjoy, which is Shenzhen.io, that we also have to program microcontrollers, and they have limited memory, so you can have just a limited amount of instructions. So you have 10 instructions of space, so you can solve all the problems in assembly language in 10 instructions, and there are internal flags. I mean, it's the most similar to the real thing. This one is quite complicated, but it's very fun. So at the end, but can you really learn programming? Well, in our study, we analyze every single game. So we have 70 games, each one saying which kind of computer curriculum is included for each game. But of course, it's impossible to format this table here. So I will direct you to the original paper. Here, this is just a bit of summary. As we saw, there are some games which are labeled programming, but they are not really about programming. Some of them are labeled like this because of the metaphor of a computer, because the computational terms appear, and they say it's about programming, but you are not really programming. It must be said that they have some value for algorithmic design, for problem-solving skills, even computational thinking, but they are not programming. Only these three last categories, we could say that you are kind of programming. And this is just generic, no? There are exceptions. Each game has a specific set of curriculum, but we can say that mostly these kind of games focus on iteration, selection, and especially the book and test, because in games it's very important that you provide feedback to the player so they can overcome the challenge and see where they failed. No? Otherwise, the games become frustrating. But some of them even include functions and arrays or classes and objects. So what's the further and indeed present work this year? Of course, as I said, since we finished your study, 70 new games have appeared. Well, 30 something are already published, and the rest will be published next year. So we could update the study with all these 70 new games. And of course, the next step is, okay, you identified whether they could be useful to teach programming. Maybe can you test them with the student? And now we are undergoing a pilot using the game Human Resource Machine with first-year students in computer science. I must be say that they are very simplistic. They are not for serious games. They are for having fun only. But maybe for the first month, for the most basic topics, they are useful. And in the undergoing pilot, the students appreciate them. If I had to recommend you any of these games, I would go for two developers, which are Hackatronics and Tomorrow Corporation. Maybe I think that they are the nicer games, that the most interesting for learning programming, even though they are for fun. And just in case you don't know, the Hackatronics one is especially interesting because there's a program named SEGames, which appeared, I think, maybe at the end of last year or beginning of this year, that the developer gives these games for free to educators. You just send an email, say, I want to use this game for my class for this reason, and I need 20 licenses, and you get 20 licenses for free. And this developer, almost all his games are this kind of programming logic games, and they are very interesting. I recommend that if you don't know them, you take a look, because they are very polished. They are really, really nice. Even the developer himself realized that even though he created the games for fun, for having fun, they would be useful for education. They have to be applied correctly. You cannot just give the game and people will learn automatically. But with this program, which is absolutely free, this is something very interesting, worth taking a look. And as I say, this is just a general summary. For a more specific analysis of each game by game, it's better to go to the original paper. And thanks a lot. That's all.
Okay, thank you very much for an interesting presentation, Juan. Now we have some time for some questions, and I would like to ask you to use the raised hand button in order to so that I can get like a list of people in the correct order who want to ask questions. Any questions about Juan's presentation today? Okay, Ben Clegg, that's the first hand I saw.
Hi, I really like the presentation. I think I've played a couple of these games myself, and I think, oh, sorry, that's my phone. I think there's some interesting things for us as people who are in the process of gamification in education. Because I think one thing I remember quite from, I think, TIS 100 is...
Yeah, I play too. I like it very much.
Yeah, it's good, right? I think the scoreboard system, right?
The interface is a plus.
Yeah, absolutely. Yeah, so a scoreboard system where it showed you your friends, sort of, I don't know, like program efficiency, I guess is the best way I can describe it. Yeah. I think that was a really interesting motivating factor. So does show that there's a latent ability for some multiplayer element to encourage education. But do you think there's, throughout your experience in doing this study, are there any other obvious things we can learn as people implementing gamification systems? Like, is there anything else we can learn from these available games?
Well, that's an interesting question, because I think that it's something that I've repeated a lot during my presentation. That gamification, or game-based learning, your purpose is education, and then you integrate some game dynamics inside. And in this kind of games, the purpose is that people have fun, and it just happened that to be useful for education. But it's coincidental. It's just sheer luck that they can be useful for programming. But nevertheless, I think that one difference I see, because I also have worked with serious games, games for programming, which we saw one example in the previous session, a simple one about the number of instructions you executed, that in this kind of games, I mean, having a very polished interface and even integrating a little bit of story, in some of them, there is a story. I mean, inside of the puzzles, there's like a meta story, that why are you doing this? Because something happened to the wall, or because you are a worker in a Chinese company, and you receive emails which have no purpose in the game apart from developing the story. And sometimes including this kind of immersive things is really interesting, is really useful. Because in many of these kind of logic puzzle games, it's just the game. Here you have the puzzle, and when you finish the level, okay, next level, and then next level, and then you finish. At the end, you finish the game, and that's all. And that in some of them, there's this small story, that interlinks all the levels. I think that is good for engagement.
That's a very good point. Yeah, thanks a lot. Cheers.
Okay, next on my list is Badish Adic. Sorry if I mangled your name.
It was a really good pronunciation.
Oh, okay. I'm surprised. Oh.
I like the idea of having the ability to replace replace the process of building a serious game with something that's already available. Because as a personal story, I have a project which is also in this conference in the last day. It's a serious game for teaching people how to review code review. But the problem is we had some experiments. So we tried it in a class with like 100-ish or so people. But when I send them an email about that, at this day in class that you are going to play a game, even if I say a serious game, students don't know about that concept, and their expectation is that they are going to be playing a game, and I can't meet their expectations. So if there was already something that was available for my purposes, I would certainly be down with using that. So I think that's a huge benefit if the game already exists, because I mean, people who are going to be developing serious games are not going to be as in numbers, not going to be as strong as game developers, or even in skills, because I'm not a game developer. I mean, I'm a master's student, but I'm trying to develop a game as a part of my research, and I can't compete with them, So if the ability to replace it with something that is already on the market, it really resonates with me. That's why I think what's made here is valuable.
About your reflection, there are some interesting things, that I was looking down because I was writing on a notebook in order to not forget, well, first I'll begin with answering something which is a bit philosophical, but sometimes applied, that a game is a game when you can choose whether to play or not. But it's philosophical, I say. And the moment you say to someone, you have to play this game, and it's no longer optional, and it's no longer a game. This is perfect. It's very philosophical, but it's something that I like saying. Then, of course, there's the next thing. That, as I said, the concept of fun is subjective, is fuzzy. What someone likes and considers fun some people will say you are crazy for liking this. And I'm not just about programming games, about any game. If you don't like football, and not even video games, any game. No? If you don't like football, and someone, your teacher said, today you will play football, you won't enjoy it because you don't like football, even though everyone else likes it. No? So this is always something that you have, I think we have to be a bit careful. No? That something is not a game does not mean that automatically everybody will like it and will enjoy it, because there are different genres and different kind of things. Maybe this touches a little bit what you say about the expectations. Nevertheless, what I agree is that when you look at some serious games that have been developed, no, and it touches also a little bit the first presentation today in the first session, no, that making a game has a very high cost. No, it's, I mean, nowadays when you I mean, this kind of games I presented, it's not some student that in a weekend finish the game. No, they were developed for 1 year or even more time. No, so imagine for educators who have to create a game, no, all the resources we have to develop, and no, students or players really want a very polished experience. No, with you don't need very high 3D graphics, spectacular things, but they need something which is polished, and sometimes serious games, because doing a very polished game would need a lot of resources, and maybe what we would get in exchange couldn't be so big. Okay, so now students are a bit more engaged, but I dedicated €500,000 and 1 year to develop this. No, it's the trade-off is impossible. No, so at the end, most serious games sometimes tend to be a bit simple or not very well polished, and this is where you don't meet the expectations. I've also found it. It's in my experience. That's why I said, as you said, let's see what already exists, and maybe there's some redeeming feature in these games which are already generated. They are well polished, and lots of people play them just for fun, that we can use in education. So I think that is an interesting approach. Also, a way to kind of convince students not to play this game, even though when you don't say you have to play this game, because otherwise they will hate it. If you say you have to do something, they won't do it. Is that since they are distributed, in this case, in specific case, in Steam, there's some kind of a community. There are the concept of achievements, there are guides, there are forums. There's this. Nowadays, video games are not consumed just you alone. Successful video games create a community, and the peers say, okay, let's see if you are able to get a higher level than me, or better optimization, or whatever. So I think that this is one of the important things. The way you can convince students to play the game is by creating this community. Apart from the polished graphics and having a well-done game, the community is also important, and is one way to make them be able to play.
Okay, thank you. Next questioner on my list is Thomas Auer.
Or my question is, you presented 4 different games. Did you also analyze, or can you also give recommendations which of these games are especially recommendable for which target group? For example, yes, software developers and unit testers, or people in the field of software quality assurance, or depending also on the professional knowledge, on the current state of knowledge. If, for example, if someone is interested in is a Java developer, or someone is interested in scripting languages, did you analyze on which is exactly the target group for each individual game? For example, when I am a testing analyst, which of these games should I really play? From which could I profitize? What can be really an advantage for me?
Yeah, actually, we didn't categorize by roles. No, we just went for a specific curriculum at very low levels, like, as I say, like does this game teach variables or selection, no? Or iterator, these kind of things. As I think I mentioned in the presentation at the end, and we found that some of these games have an educational value despite being generated for fun, but they are very simple. Nevertheless, you cannot learn a lot of programming with these games or just playing these games. So given this fact, you cannot go much farther and say maybe can you learn integration or for a very high-end role, because this is my experience up to now is this is a game, even in the best games, you know, let's say that the most complex that I found that more polished is something that maybe in our computer science curriculum in a university could be for the first month. I mean, you would provide a result to complement maybe the first month or a month and a half. They don't go into much depth. It's very basic, no? So we didn't really were able to go beyond and say, can you go to for a high-end role or more specific role in software development, because they are quite simplistic at the end. On regards to language, almost we look into this indeed, but most of them use made-up language. So
okay.
Maybe we could say, okay, is this imperative or object-oriented, but it's even if in games where there's object orientation, it's more conceptual than the real thing. No, these are games to help you better understand how to program when you study the usual resources in university. But just giving this game, someone will not learn how to program. In fact, the developer created these games for the enjoyment of people who already know how to program, not to teach programming.
It means it gains also the it's a fun, and the games should be fun, and it should gain the abilities for structural thinking, for analytical thinking.
Yeah,
as recognized, yes.
All of them, even the ones that I say, these are not about programming, because you are controlling the avatar with the game, but you are not creating a code or set of instructions. All of them have some value for problem solving skills. This kind of more abstract skills were also included in the paper. So because otherwise there would be a lot of games with blanks saying this serve for nothing, no? So even the ones when you don't get into very specific programming skills, they include some high level like computational thinking, algorithmic strategies, these kind of things. I must say that some games, no, I'm not sure if they are explicitly included in the paper, did use existing languages. There are some games which are about JavaScript, and you program, or you really are programming JavaScript, the real thing. But almost all other games use made-up languages.
Yes, but it may make fun. It's really exciting. Then also, may people would be encouraged to learn programming, because they see, okay, it's really exciting. It's really fun, and this can be the initial point. Okay, now I'm interested to dive deeper in this area.
To
force
people to be interested in programming, I think that they are very useful. No, like, I have this game, just try this. Did you enjoy it? You were programming and you didn't realize.
Yes, no.
That's another good approach.
Very interesting, yeah.
Okay, thank you. I think we have time for one more question. I have a hand raised from Leonardo Andrade.
Yes, I'm here. Did you have any metrics in this evaluation to assess how good these games were in teaching a certain concept in each concept that was evaluated?
Yeah, we consider having, instead of saying yes, no, having some kind of metric like from, I don't know, 1 to 5, how much does it help in that concept? But at the end, given the number of things we have to survey, it was a bit complicated. So we decided to just go for a simpler approach that's saying this concept is included or is not included.
Okay, thank you.
Furthermore, we didn't decide on the methodology to decide what is a 1, what is a 2, what is a 3, what is a 5. No? Maybe in further study we could just sit down and define this, and then we could provide this granularity. But since we didn't have exactly a methodology about how to decide what would be its level, it was very difficult. So I just went for the simpler approach.
Okay, thank you.
Okay, thank you very much. So we had a lot of interesting questions for our first paper. The second paper today for our session is titled Towards an Empirically Based Gamification Pattern Language Using Machine Learning Techniques. If you could, hi Alex, if you could maybe introduce yourself and introduce the co-authors of your paper, what university you come from, and then please go ahead and take the floor.
Thank you for the nice welcome. My name is Alexander Schneider. I'm one of the authors. I will present you the research results from our project on behalf of my project lead, Professor Dr. Voigt, and Matthias Kriegbaum. We both are research assistant at the University of Applied Science in Nuremberg. So I try to share the screen.
Yes, we see it. Perfect.
Oh, nice.
Okay.
So, yes, here I am for the presentation of our paper. We already presented ourselves and now start directly into the topic. Our topic is that we want to empirical find a gamification pattern language. And so we started in the beginning, at the very first beginning of the problem. And if you look at this piece, you see two people playing a game. You see a chessboard. It's a board game. You have a game board. You have game pieces. You have time limit. And you see elements which form a game. And this game gives emotion. So this is a game you can play. And if you use such elements in a non-game context, you call it gamification, we already know. And here is a Fitbit in the fitness sector where you use one of these elements, here's like time limit, to gamificate the sport. This is gamification, we all know. You have to transfer the elements from a game context to a non-game context to generate motivation. That sounds really easy in the beginning, but the big problem is in the game context, you play the game voluntarily. This is you only want to have fun. The game is there to have fun. So all elements you find in a game, all game pieces are made of to generate fun. In the non-game context, this could be, for example, a work. You have a context, this is not made for fun. So you have things you have to do by purposes. You have to do because they are necessary. So the elements you find there around this context, this element you use there are not that funny like they are made of a game. So if you want to gamificate something and to generate fun in the game, the non-game context, you find a mixture how you can use these elements to generate this fun and bring them together. But you have two completely different domains. One you have to do and they don't make fun, and you have the game elements they made to be fun and you have to bring them together. And for this reason, we try to find a way to bring these worlds together and find a systematically way of mix these elements of both worlds to get it together and use it for, yes, a systematic way to achieve gamification instead of trial and error and see what happens. And this is a research object of this project, to find exactly this match between game elements and real world and try to make it better. This project is called Empomos, and in the rest of the presentation, I show you the steps we made to achieve this. and with some examples what we made. So first, we started in the analog way, and we go back to the ground, to the very first ground, and searched for the game elements. That's why we call it empiric analysis. So we don't use the literature and read for what elements are already there and use it. We started in the beginning and say, okay, let's go to the board game domain and start playing games and see what patterns we will find there. So we started playing games, reading game manual, game instructions, and from this, what we saw there, we made our hypothesis of what patterns already existed. We use the board game domain because we have really one big advantage in board games, because all rules inside a board game are written down in natural language. We know everything, every aspect of a game. If we use computer games, we have the problems that we only see what the game screen allows us to see, because the main mechanics are inside the source code. We cannot see what is there too, and we cannot reach it. We can play hundreds of hours a game and don't see everything. So in a board game, we have a written manual. So everything which is inside this game has to be in this instruction. So we started board games and made our hypothesis. Problem with this approach is it took very long. So we use computer science to make it a little bit faster, but we have text. So we go in the first step to make it in a form a computer can use it and transfer it to a database. If we have the data in a database, we can use machine learning tools to analyze the data and structure we already found. And from this, we get a better insight in the research results, how the game elements connected we have found in the games. Based on these structures, we developed game design toolbox. This is a workflow. It's basically a board game in itself, but it's a guided workflow how to use the structures we found in a real world project, and helps people to use these patterns to create their own gamification projects. In the next step, we put our analog game box design here on the analog world. This is a really board game, and put it in the digital world, and created a web app, so you can use this game also in the internet and use this method. Not that you sit at your table, you can play it all around the world. And in the last step of the project, this is the bleeding edge of the project, we developed an AI system which helps you a little bit more to get the insight of the patterns we already found. You don't have to search it by yourself. You have a system which helps you to select the right ones. This is a bleeding edge, so we're not finished there. And yeah, the story goes on. First, how do we get our hypothesis? We have a really treasure here in the city of Nuremberg. It's called the German Games Archive. It's an archive which has a job to collect all German board games ever came to the market. So we have board games over board games from 1945 to the present day, and it's about 30,000 board games we can access. As a first step, we sent our students into the museum, into the archive, and they had to play games. So they go there, they play games, and they write down and document everything they found in these games. They have to play and document. So like examples, they found a pattern, a chance, and it's implemented by a turntable. And they play, and they found a pattern time limit implemented by a timer. So they play, write down, and because writing down on a paper is really hard to work with a computer, we created a custom content management system where they had to put all the things they found in the system. So we have information got from this manual work. We know which pattern was in which game. We know how the game was called. We know the context in which the pattern arose. We know the problems the pattern solved inside the game. So was it used to start the game? Was it used to end the game? Was it used to interact with the players? And they also document which questions they had about the patterns and which other patterns was needed to solve problems the patterns self-made. So we get information with the text, everything was collected with text, and he saw the first structure of the patterns. And from this one, we could derive our first pattern. In the next step, we started to make our treasure from the archive more digital, because everything we had was a bunch of papers. The archive scanned the things, then we had a bunch of PDF files. It's not that better, it's only digitally, but a computer cannot work very well with pictures. So the next step, we had to make text out of it, and we started the OCS process. And now we have a database where we have every single word in every game instruction at which possession, and with confidence, and computer say, hey, this word is das Ziel einer. And based on this one, we can generate text the computer can use. And this was the first thing we had to do for our machine learning, because now we have the instructions in text form. And we gave it our colleague computer, and he gave us all our patterns, and we was finished. No, just a joke. This little guy don't want to work, and we need another way. And if you go the AI way, it's a very stony and hard and bloody way. We can use this little guy. We had to set up a bunch of technologies to store all data we had, to process all data we had. Is getting really, really big. Basically, we use a Spark cluster to process all the data we have with a scikit-learn framework for the AI stuff so far, and a different bunch of databases for every specialized data we had. Because it's a presentation about gamification, this is only just a little slide with technology to show you that we need a little bit more than a little robot. In the end of that process, or at the beginning of the process, if you make AI, you need training data. If the computer cannot see your text and say, hey, cool, there's a pattern, you have to give him training information. For that, we created a search engine where all the text we already gathered put inside, and now you can search all instructions we have for words, for phrases, for patterns already found, and you can say, hey, give me now a search result where the word Teufel and Würfel inside, and now we get the result every games, which is called our ID from the game, and the text pieces where the word we are searching for is inside. We can download the text, read the patterns we found, and tag which pattern we found in this game. So we can say in this instruction, we found a bunch of gamification pattern we can use, and now we know which pattern are inside which games. This is repeated about 40,000 times, and now we have 4,000 games with about 40,000 tags which connected to the instructions. And now, after this work, we can start with the AI and to analyze our pattern structure inside the instructions. Here you can see a support vector machine where we tried to train the system to recognize patterns inside a special game instruction. Here we searched for a pattern called victory points. It's about if a player has to collect points to win the game. So we trained the system with a support vector machine. It's a statistical system which detects words or bigram or trigram or four words together, which are typical for this pattern. And so the system starts and gives us a feature list. Here you see the most 20 on the left side, the most 20 typical words for a special pattern. So if we search for victory points, you get at the top rank the most, who got the most points. Sorry for that, the results are in German because this is really output of our engine, and because it's a German board game archive, we have mostly German text, so our results from the computer are German too. So I try to translate the most important stuff for you. On the right side, you see the 20 negative indicators for the victory points. And if you see something like as first, at destination, one time roll dices, if you find that ones is a really good indicator that you don't have victory points. But if you interpret this data, so AI gives you good information about the context, but the human has to show the data and see what they really mean. And here you can really good see, if you show the patterns, that this one is really good at the pattern arrival. This means, okay, as first reach destinations, this is a pattern, you come first to any target. So here you collect victory points. There's another game is arrival, and you can see it's this analysis. There are some patterns don't fit well together. If you go from A to B, it's completely the other thing as to collect points. And with this information, we can now see automatically which pattern are inside our instruction without reading it, and can do it in less than a few seconds to see which pattern are inside. And with this knowledge, we started to build up the element graph and how they are together. This is a basic work for our project we have. And here you see a graph. Now this is 4,000 games. Every dot is a game. And the connection between these dots, the games, which pattern are inside these games. And this we have made with a cluster algorithm to put games together which consist the same patterns. So we can build groups of games which consist of the same patterns, are made of the same ingredients. And if you do this and let this cluster algorithm run, then you see some interesting thing. If you get the output, then you get a cluster, the blue one. This is all games which have some cognitive abilities. It's the name we gave to the cluster because the computer only say, hey, I found something. They have something in common, and this is the games, and we have to put a name on it, a label on it, and the results. And here you see, oh yes, and our cognitive ability games. And the wrong one, we found a large cluster of trade, role play, and business games. And we find a large cluster here in green of run and dice games. You know the games like Man, Don't Be Angry. You have to roll a dice and run to a target. It's a typical group of games. And some collecting games. Every game you have to collect the most. If you collect and get the most at the end, you are the winner. There are the typical groups of games, and this we can already get out the information we have retrieved from the AI machine. This is the input for the next step, is creating our game Dissolute Box. This is a workflow where we use this information, how these elements are connected together to get this workflow and set up the system. Basically, it's a board game. In this board game, it's a card game with some game pieces. You can put down the network as you have seen and the connections of the elements of the single patterns and how they're connected, and lay down a graph. How these elements are connected, which came from our database, is inside the spiral block. Here you have explanations what these connections between these elements are meant. So every card is an element, and you have connections between these elements, and you have now a game where you can try to find a gamification solution for your problem, and how to map your gamification patterns, which we have found, to your problem. There you have hints inside this spiral block, so you can get this mapping between real world and our gamification world in a systematic way. So most problems is you don't know which pattern you have at stake to use for your solution. And so we have a database, you have a problem, you can describe your problem and find a solution for your gamification problem with a structured process which leads you to a solution. This is exactly this project which we use for the thing.
5 minutes, Alex.
Thank you, I will get it.
Okay. Okay.
During this process, to getting this workflow, we have seen give somebody this stack of cards is not really useful. Actually, you get 104 cards in the moment and have to put it to a network. This doesn't work. So we have a workflow with a guided moderator. He helps you to moderate this process. You go step by step through this workflow. And with this card set in this interactive with tasks, so it's a gamification by itself, by the sport game, you come to your solution for your special problem. We have already used this with a developer group from Bosch. The solutions which came out of this one are no games at all. They can also be changes in processes. So our system creates no games. Our system creates a new process how you can improve something with gamification methods. Deutsche Museum Nuremberg or Stadtmuseum Tübingen use it for exhibitions, how they use for pupils, e.g. to come to the museum and show the exponents. As a Nuremberg University, we use it inside, and there's a project in Nuremberg, the Mutra. It's used for the drug and addiction counseling. It's a PhD work of Benjamin Löhner. The work is still in progress, and he used our system to develop this counselation for the drug addicted and to make make the cancellation process better. E.g., they can decide when they use a date, and except to give them a form and fill it, they have much more freedom to choose which way they go. It's combined with an app. We don't develop this. We made the tool that they use it to make it gamification. So we give the process to form such a thing. This is a PhD is running. In the first page, I gave you the link. In the end of the PhD work, we also get the result, how good it worked out. In the next step, we make this on a digital prototype. So we moved this thing back to the digital world. It's possible to play our card game now virtual. This is called Tabletopia. It's a simulator for board games in a browser. So you can put everything you have seen on the card game in virtual environment. You also get the spiral block as a helping system. And it's really useful if you want to have a meeting with people not in the office, so you can also use our system now in the digital world. Now, the bleeding edge of our system and where we go. And the next step is our AI system, not only to give you a network for lay down, sondern a system who helps you which card you could lay down. Because if you take all of the patterns, is 104, actually we have 106 now, so it's getting more. You have a bunch of possibilities. It's not really to know how much or how big this number is, it's really big. And to test all combinations is not feasible. So you need something to help you to select which one. So we developed an AI system based on this information of the graph, which can you answer these questions. I have 3 elements, which is the next one I could possibly lay? And so we can show them the card we have. This is also the same cards you see on the game. You can select which cards you already have, or in your other context, which elements I already have in my non-game context. And then the system can advise you, hey, if you have these 4 elements, you should use the 39. You already 4. You can use 39. You already have it. You already have it. You don't need to change so much. Or it can say, OK, you have here 5 elements. If you want to take a new one to this 5 and make your network larger, I advise you to take you the one. It's called randomness, and it mixes it really good up with I steal some card. As the next thing, we want to improve it a little bit more. You don't have the patterns and ask which pattern I can use together with the patterns I already have. We want to say that you say, I have a problem. Which pattern solve my problem? So I go a step up and don't think in patterns, so think in solution. So this is my last slide. Our project is called Empomos. This is not only a short word for empirical analysis and so on. It's also a Portuguese verb, and Empomos means something like let's do together and put the wine on the structure who supports the wine. This is exactly what we want to do. We don't want to invent game elements. They don't want to invent wine, it's already there. We want to invent a system which helps to set the elements already there, and to put it together to find a good solution. Thanks for the audience.
Okay, thanks, Alex. That was an interesting talk. We already have the first question in the chat by Grisa Vianney Maturana Gonzalez. What is the name of the game in Tabletopia? Could you maybe go back to the Tabletopia slide?
Oh, I can go back to the Tabletopia slide, and I can answer in parallel. There is no link so far.
Oh, okay.
Oh, I have to go far. Go.
Is it being slow?
Yes.
Yeah, sometimes
I found
with
it.
sharing it's slow.
So it's a project, and if you start such a project, we send an invitation link. So it's a private project where we send an invitation link. So I hope my project leader will not kill me, but if you're interested in the project, you can write an email to us. You find the email addresses in the paper, and then we can give further information on how you can attend or get a demo or so on. So far we have no public link, but if you have a session, you get a private invitation link.
Okay, thank you.
Okay. Any more questions for Alex about this system? I see some hands raised. I'm not sure if they're raised from last time. I see Ben Clegg, your hand is raised. Is that still from last time?
Oh, sorry, that's from last time.
Okay. And let's see what. Badish, is your hand still raised from last time?
No.
Okay, so you have a question. Yes.
Is the system, then the current state of the system, as far as I understand, is like a feature consultation. So I have this problem, I have these features, and it suggests me what easily can I add to the game. Is that correct?
Basically, yes. We have a structure of patterns, and the patterns we have already researched which pattern are connected often in other games. So it's just the complete system is empirical. So we don't think about which pattern could be useful together. So we found this connection inside the games. We search the games and see what's together in one game. And based on this information, we can give advice what you can also use.
Is that available?
The basic,
like, for example, if I'm designing something, can I use it like now, tomorrow, perhaps?
Yes, there's a workshop concept which we are developed with external partners. They make exactly this training sessions, because so far we need a moderator who you guide you through this process. And there we are start working to get this on stable feeds to make it available for all. About when you can use a system, I can send us an email and we can give you information when it goes to the public and is useful for everyone to use. What we already know is if you publish only the cards and say, here a bunch of cards, it doesn't work out. We tested it in the first things, in the first workshops. We developed our workshop. We use the workshops to develop as the next step. So this is work in progress. And in every iteration, our system gets better. And the first thing we had 104 cards for one topic to the people on the workshop. Big problem if you have 104 cards and only cards, and you need about 5 seconds to read a card. You spend plenty of time only to see which card you have. So in the workshop, we already have specialized topics for specialized group, because if you write software, you don't need every 104 cards. So we have pre-selected cards. And we are in the workshop, we only have a starting box. This is a guidance where you put you inside this pattern, because we have this there are patterns which form the structure of a game, and patterns which implement, for example, only single rounds. So there are different hierarchy of patterns. So if you start with the wrong pattern, you make much work and don't get a good solution. So if you start the wrong end from the tree, it goes in the right. You see the large number, but we want to make a system where you start with 1 point and go to your solution in a straight way without avoidance. If you go from the other side, you have the 10 power of big number, and this is not helpful. And that's what we try to find exactly this workshop to make it more useful. For example, as an AI system, this shall help to guide you. So we don't need a person who train you. So the AI system can ask you questions like, hey, what do you want to do? And then give you an advice and say, hey, I would use this 5. Because you every time need the mapping between real world and the patterns. And this is the most crucial part in the whole project, to get the mapping between real world and patterns. because if you don't get it right, we see, if you don't get it right, you have points, patches, and leaderboard. And every gamification solution has these three things. And this is exactly not what we want.
I understand that.
Okay, so let's see. Do we have any more questions for Alex?
Yeah, here.
Yeah.
Maybe do you have a game like Carcassonne, for instance, categorized by the patterns? We can do that with your software.
Categorized by what?
Again, any game, you have a game and we can find the patterns in this game with your software.
Yes, we can find different games which are similar. This is one idea in which we develop. Also, we can make advices about, if you give us a game you like, we can say, perhaps you like this game too. Mm-hmm. And we can search for games which contain special types of pattern. So we're in the beginning of the project, because so far we only know that a pattern is inside a game. So far we don't know how these patterns are connected inside the game to each other. So if we say there's randomness in the game, we don't know how often is randomness in this game. E.g., randomness could be only used to determine the start gamer, who starts a game. This is random. A completely other game is no randomness. E.g., you have chess. Chess has no randomness at all. But if you use the start gamer as random, then our system would say there's randomness inside. This is where we do research. And the next step is to find the connections between the patterns inside the game. So far, we can only say these patterns are used often together. And in the next step, we want to make it more precise to say which pattern does, from the text, which pattern uses another pattern to get the structure of a game.
Mm-hmm. Do you have another ideas for the future work?
Oh, we have such a bunch of ideas. We don't have enough people to work on it.
Yeah, because I was thinking that your project is very useful for my project. And I want, yeah, because for me it's a big problem. I just design games changing the metaphor of the original game. And with your software, I can have the elements of the game, the original game, and I can change that, use that elements and create another new game changing the metaphor. And if you already have characterized the game, for me, it's amazing. That's the idea.
We've already made a classification for the game archive, because I have many games and need a classification for storing the games. Physically stores. It's only a big problem, and they have a classification which came from 80 years ago from the first owner of this, and the classification is strange, and so we made a classification based on content.
Okay, so nice.
So they have new signs they can put on the boxes in their cellar.
But I think you should write to Alexander, and maybe you can think of some sort of research cooperation to do together. Yeah. Okay, lots of interesting questions, but I'm afraid I'm still going to have to try and keep us on track as far as time goes. I'd like to thank Alexander again for a really interesting talk. And our third talk today is about Tool Stackers, a board game for software engineering education. If you could first introduce yourself and your co-authors, and then you may have the floor.
Thank you. Let me just share my screen first. Actually, I won't be very long as well, because mine was a like preliminary work entirely, so it's an extended abstract. So at most, I think I will take like 10 minutes to give you all the gist about the project. My screen is visible, right?
Yes, we can see their screen and we can hear you very well.
Okay, thank you. So this is a start of a project for us. I am Barış, and Eray Tüzün is my advisor. We are in Bilkent University in the capital of Turkey, Ankara. So the game is called Tool Stackers. You'll understand why in a couple of minutes. So the motivation, what we are doing is essentially we have a course. He is the Mr. Eray is the instructor of the course, and I am the TA. And we have an idea that directly targets the contents of this course. So it's not something general, it's very specific for us, at least from our perspective. So the course is called Application Lifecycle Management, and it's an industry-facing course, meaning that it tries to prepare people when they are going on to the junior programming jobs. So how modern software development happens is a little bit different than what you tell students in their first or second or third year. It's gotten so complex that in order to manage all the other stuff that's happening, you can think this in the context of agile or something like DevOps paradigm as well. People are using more tools than they are writing plain code. So I ran my test, I got some text from Jira, then I got some, so I ran my tests, they have some output, and there was some errors. For example, a tool like Jenkins ran the test, then the errors were sent through their integration via Slack. Then I got a message from Slack that this test didn't run correctly in about 10 minutes after running all the tests. So people work in this manner, and this course tries to provide students with a bit of familiarity and perspective into what they are going to be doing once they got into a top-notch software development job. So that's how the course works, and we want to build a first exercise for this course. Maybe it's a game that is going to be played by the students in the first week. So that's our perspective. It's an in-class activity for the software engineers course that I just described. And since we are going to try doing this with the new project groups that students just formed, it also works kind of like a team building exercise as well. So perhaps I will tell you the objectives of the course first. We want people to understand roles and responsibilities in large-scale software engineering in modern software development. So there are a bunch of concepts that course touches on week to week: source control, build management, software testing, change management, and project management. We call these process areas. And one of the key points, since I was the TA of the course, and like people are asking me their questions via email or in office hours, one of the key learning objectives to the course is understand how everything works together, which is called a technology stack. But since in order to utilize the particular technology, people are using tools, so in order to simplify it, we call it a tool stack. Once people understand how everything works together and how they are integrated, especially, then they are very ahead in the course. But if the student is not able to do that, they struggle a little bit. The best students are the ones who got that key point down. So what we thought of is to design 2 to 5 people. 5 people actually is the target here, because we also want to do this for a whole project group. So we are designing a 5 people board game that has 3 types of cards. One is a tool card. The second is an upgrade card that upgrades your proficiency with the tool, hypothetically. So if getting a tool card means that you just adopted the tool, but you don't necessarily have to use it. That's the metaphor. Upgrade cards you access through while playing the game. So, for example, you might be able to get one in each of your turns. The metaphor there is that you are spending some more time with the tool, and now you are more proficient at it. Then the game is about collecting tools, building a stack, then upgrading the tools in the stack. So then you are getting yourself familiarized with a tool stack that you have just built. And there are also event cards that have a condition on them. And if the tool stack you have can match that condition, so you have the proficiency in the necessary tool area that the event requires, then you can also benefit from the rewards of the events as well. So I made some, by the way, this is all preliminary work. It's just, I have just the design of the game. I didn't get to realize the design yet. So I made some examples of cards for you. So this is like a tool card. Jira is a software management / issue tracking. It's very popular, developed by Atlassian. And here you can see that the type of the area is project management. We have other areas like issue tracking, perhaps something like the code review, the continuous integration, test management, all of those. We have some flavor text, some, like, since this is a card, we need some graphics on it. And this is a tier 1 card. So player just acquired this. They didn't get a chance to upgrade it yet. While playing the game, they will get upgrade cards, which is something like this. It's a very basic function. It increases the tier of the card, and 3 is max. It actually depends on how long we want people to play it. So this is completely arbitrary. It could be also 5, but then the victory condition will change and people will have to play it longer. This needs to be play tested and adjusted, but the initial idea is 1 to 3. So we have also event cards. This is perhaps the more interesting part. We have a event that is associated with using the tool in the particular area in the stack of the player. So what means is the event is called here automated testing. It rewards you with an upgrade card. And what you need to do is described here. You need to automate your functional tests. This is essentially flavor text. But in order to do that, you require a tier 1 continuous integration tool in your stack. So if you have that, then you can realize this event and you get an upgrade card. This is the harder version of this event because these are connected. So automated testing requires tier 1 knowledge in continuous integration essentially, but if you want to do continuous deployment, you need at least tier 2 in continuous integration tool in your stack. So these were all the game elements. Now the game flow it's a turn-based board game where each player starts with a random tool cards. So essentially, most of the time, they don't have a complete stack. They don't have one of each type of tool. They have random tools. They start by drawing. If you have 5 different tool types, then players start with 5 random tool cards. In each turn, the players can discard a tool card, not exactly discard, but because we have a limited number of tools that we can manage to take from the industry for realism purposes. We don't want people to discard the card, but put it on the pile back maybe, and then shuffle the deck again. And then they can draw a new one. This is done in order to have a complete stack. Even if they're all tier 1s, you need a working like selection of tools with the source code that you are building. Then another thing they can do is that they can draw a card from an upgrade and event pile. This has a selection of events and upgrade cards. Getting an upgrade card is the easier thing here because this needs conditions to be met for the upgrade cards. But number of these is going to be a little bit less. This is here to just get game going, so players aren't stuck anywhere. They can also trade any type of cards as they wish. So, for example, I am looking for, there's a bit of strategical depth that I tried to put in here. For example, I don't have a complete stack, and all of the people have completed their stacks. So I know that the number of the cards in the pile that I need, the type that I need, is lesser now. I have lesser, like I'm kind of counting cards here. So I then can try to draw an upgrade card and try to trade the upgrade card with somebody for the type of tool that I require. So that's also a move that they can do. They can trade freely. So the win conditions for the game are first that players need to complete their stack. By the way, in order to fulfill the conditions in the event cards, they also need a complete stack. Because if you don't need a complete stack, even though this requires continuous integration knowledge, you are not going to be you are not going to be able to do continuous development efficiently, from our perspective at least. So the win condition first is to complete a stack, then it actually turns into victory points. So the more total tiers of cards you have in your stack, if you reach a certain number, then you are the winner of the game. If you have 5 cards in your stack and they are all tier 2, then you have essentially 10 victory points and you win the game. This is the complete overlook of the game. So the challenges for this is that I really designed this to be printed. I didn't necessarily think of the digital format, but then the pandemic happened, and now we are in not exactly distant, not online all the time, but we are doing a mix of it in our school. And for the purposes of this, I really would like, for the printed version at least, people to be in the classroom environment. So I perhaps may need to implement the digital version as well. Another challenge for this is designing event cards, because you really need a good insight in the industry and what happens, but you can't be too specific otherwise, because these are what we want people to learn. This is integrated with this, or perhaps this happens and then provides you with this. So we can't be too specific either, but we need a good amount of event cards for the game to work. That's also a challenge. It requires a bit of maybe process mining, if you will. And we also need to be able to measure that the game did well. That's also always a problem for me, because I don't want to just directly ask people, did you enjoy it? I mean, I trust their answers almost all the time, but that's not good enough. I want some statistical data when I can have it. But quizzing people before and after all the time, for playing a card-based game, is not essentially ideal. So I have a dilemma in there as well. So the purpose of this study, that the extended abstract I sent into the conference, is essentially to pick your mind about it. So what do you think about the things that I've talked about so far, or do you have any suggestions for a project like this?
Okay, thank you very much. We already have the first comment in the chat from Grisa again. You can use Mega Plus for evaluating. Could you tell us a little bit more about that, Grisa?
Yeah, sadly, I don't know what that is. If you can explain, it should.
Yeah, of course. The Mega Plus is evaluating software for games in computer science, and it's very nice for that. And also allows you to ask about the enjoyment, the learning contents, and a lot of things. And it's very nice. It's very new in the academics, and it's from University of it's from Brazil, Santa Catarina. It's very nice. I just use that for evaluating my games in this moment, because it's a complete questionnaire about the usability of the game.
Yeah, that works for the people's satisfaction and measuring their engagement as well. But I also wanted to be able to get some statistical data, but perhaps not very doable with a in-person printed card game. But if I do the digital version, I'll also be collecting some statistics about time to make a decision and other stuff as well. That's the challenge I was talking about. But if people have made a tool to get the questioning people step easier, that's something I must use. So thank you for that.
Yeah, and another thing that I had the same problem with, because my games are usually in a physical way, and also using the Tabletopia is a very good platform. You can design, you can create your game in that platform, and I just made some experiments, and you can put any person can enter to the platform and use your game. And after that, you can do a form of Google with the questions. It's a good idea for practicing. I have some examples. I just have a protocol for use that, and I can show you anytime when you want it.
It's like a game engine, right? For this type of games.
Yeah, it's a platform for create board games. And you can find all the elements. You can create cards, you can create boards. You also have the characters, a lot of things. And each player have the option of have a hand, and the hand is private, really. It's very nice. When you want, we can talk and I can show you my games and how you create it and which one is the best protocol for use it.
That would be actually really great. Thank you.
Yeah, because I just had the same problem in this pandemic situation, and all my games are physical, and I just have to translate all my games in a virtual platform.
But with programming related, like serious games, if they are programming related, you don't really have that challenge. But if you are doing something abstract, like perhaps you are doing or I am trying to do here, then it becomes a challenge how you are going to realize it.
Yeah, it's a little hard, but we already have some solutions.
Good to know.
Okay, thank you. Good to know. I see a raised hand, Thomas Auer.
So from before.
Oh, okay.
But also have a question. Yes. Yes, as a project, it's really very interesting. It's very interesting. What I want to ask you is there also the possibility? You're still working on the further development of the project. Is it also a possibility to join it? Is it developing an open community at your university in Ankara? Can you also join it, or maybe is it possible to join it in a later stage? Maybe, for example, to participate with own ideas. For example, especially with focus on project management. For example, to sign a further game unit on project management, for example. Or that it can be adopted on a special topic, for example, you can use it for further training, or that you can also use it to learn to design for additional for a course unit. For example, if we are also a course training provider, our company, maybe can we also use it, for example, for teaching software testing, test automation.
Yeah, actually, you should apply this like a general idea to any concept that you are able to break down. Mm-hmm. So the essential idea here that I break down application lifecycle management into 5, maybe 6, if you are trying hard, maybe 7 different process areas. Mm-hmm. But the game elements are not really about application lifecycle management. It's a metaphor. So if you have a process, any process that you can break into 5 parts that need to happen simultaneously, you can apply this exactly as it is to that process as well. Mm-hmm. If you want this to focus on project management, you can find sub areas for project management, maybe like task scheduling, or I can't think of it on my feed at the moment. But if you can break it into a couple of chunks and they make sense together, then it should be possible.
From my side, I'm especially interested in the topic of test automation. We showed it also before. So it is especially my part also.
Yeah, if you can break down the state diagram. So in this version, all the process areas need to be there simultaneously.
Okay. Mm-hmm, mm-hmm.
But in your version, test automation, I think, has a stricter flow. So it needs to have 1, then 2, then 3. Not necessarily mm-hmm. in any combination, but a specific combination. So you can change the gameplay to make people arrange the cards. I'm not making them arrange it. But if
Okay.
you make them arrange it, they will also get an idea about the flow. So they
Okay.
still need all the necessary components but then they need to be able to arrange it in the correct way.
Okay. Okay. It's interesting.
Okay, thank you. I see another question, another raised hand from Vladimir.
Yeah, sure. I was thinking about like you said, in the industry we have all these events, and you put the example with Jenkins and the message on Slack, right? So I was thinking that, well, this has happened to me sometimes, that, well, some of these events are not isolated, right, and are not like in charge of one area. Let's say, for example, you have a deployed application and your application starts failing for some reason, and you get a notification for a failure message. Then you have everyone involved, like project management is trying to get the client to be cool, and the developers are trying to debug everything. So I was thinking, like, maybe is there a way to chain like the event cards, so one event triggers another event card or whatnot? So if that makes sense to you.
Yeah, it makes sense, and with like some tweaking, it can be done. Maybe you do something like this. You give sequences to event cards. So we have 3 red event cards. It's event A, B, then C. But for C to happen, you need A to happen, then B to happen, then C can happen. If someone draws C, since A and B is not there, you can put it on the board. Then if somebody picks B, then you can put it there, or A. When the chain is completed, then you trigger events back to back. A happens, then B happens, then C happens. And there's some strategical depth about that as well, which is nice, because people are seeing that C and B is there, and they might make a strategy out of trying to prepare when A is drawn. It might be a nice little element, but also might be too complicated for, like, if there depends on how long they are playing the game, right? Because we don't want something like that, like an RPG complexity for an hour of playing.
Yeah, sure. Yes, yes.
The game mechanic is good. The idea is good.
Yeah, sure. Thanks.
Yeah, thank you for the idea.
Okay, in the chat, I don't know if you've seen, there've been a number of posts about creating games on Tabletopia, and also using the board game simulator on Steam. So those of you who are thinking about, setting up your own games, maybe this might be 2 good places to look: Tabletopia and Steam. Okay. Any more questions today? As we're done a little bit early, any questions for any of our 3 presenters? Don't see any raised hands. Don't see it. Okay. Since this has been a pretty exciting topic, and there's been a lot of back and forth and a lot of interest on this topic of gamification, we had 2 separate parts of workshops because we had so many good papers on gamification. Tomorrow at 6 o'clock Central European time, there's going to be another tutorial on this topic of gamification to improve engagement. And this tutorial will be held by Tanya Vos and her colleagues. And I think they're talking about an Erasmus project called Impress to explore the use of gamification in software engineering education. So I would like to welcome you all to take part in this tutorial tomorrow night too. And I guess we could wind up a few minutes early. I'd like to thank you all for your contributions today. I think we had some very interesting presentations, and also a lot of help, suggestions, and back and forth, giving comments about what other people have done, what other groups have done. And I think maybe we formed the basis for some cooperations between some people in this group here. Thank you all for your participation. I wish you good night here from Germany, and we'll see you tomorrow morning, probably at 9:30 for the keynote.
There's
Thank
still
you all.
one question.
Okay, Thomas,
One
sorry.
question to Chris about the evaluation to the Mega Plus. Can you also is it for free? Can we also use it for the evaluation of games? Is it possible? Can you provide the links for? The question to Chris.
Grisa, are you?
Yeah, here. Tell me.
We have a question
yes.
about Mega Plus.
Yes.
Do you have links for that you could post? That some people are interested in about that for evaluating games.
Okay,
Yes.
I just put a link in the chat.
Okay, great.
I found it so interesting that I immediately went to
okay.
That's excellent.
Excellent.
And it's for board games too, I see. So
yeah, also they have a version for kids. That is an interesting thing. And
okay.
Yeah, they have questions for kids, and for me it's very interesting, but I always work with high school, bigger persons, I don't know, adults. Yeah, but it's a very nice, and it's based on the ARCS model. I don't know if you know this.
No, not yet.
Okay. Yeah, but it have a very good references, and also have references related to the ISO. Yeah, it's very nice. You can check.
Yes, the references is very interesting. If you have some references, focus it how you, especially how you evaluate the progress of the games. This is also very interesting for my research.
For all, I think so. Because that is one of the hard points in our research.
Okay. Thank you.
Okay, sorry about that, Thomas. I thought your hand was still up from the last question. I'm sorry, I didn't call on you. Okay.
No
Any more questions? Any more questions? Because especially this type of exchange, I think helps all of us. I wasn't aware of this MEGA method, and to have the paper on ResearchGate. Thank you, Johan. This is a huge help. Okay.
Thank you.
Any more comments or suggestions or questions from the group?
I don't know. Also, in that paper, you can find an interesting way for evaluating games. For me, it was very interesting. They have a process map, and you can see the steps that you have to follow when you want to evaluate in a game. That is something interesting that I really found in that paper. And one of that things is the ethical approval of the university. For me was something new because I just never applied it in that specific format. I really enjoyed that, to have that steps for evaluating games, and I think that could be very nice for us.
Did you also describe some evaluation methods, for example, the technical acceptance model, some more research approach? So for the what is the difficulty of the game? What is how easy it is to use, and what how should it be designed that it is that people will use it, that it to use it will be more easier.
Maybe you can see my screen. I don't know which one this is. You see it?
Yes, I can see it.
Was available a moment ago, the diagram.
Okay. I just moved it in the other, and I have to screen, sorry. In this one?
I can see it now.
Yeah, this is the steps, and for me it was very amazing because they consider a lot of things, which were your goal and a lot of steps. And for me it was very interesting because I never see that before. And also, this is the Megaplus. This is the process that I told before. And at the end of this project, you can find the questions, the questions, and also how you can have the results in different areas: usability, challenges, satisfaction, social interaction, fun, and it's very nice. For me, it's a very interesting tool, and maybe you can use it too. That was.
That's very interesting.
And also they include a demographic information that I don't know if you have the same problem to me. Yeah, because we need a lot of things, consider a lot of things when we want to evaluate our games. I think that this is a very nice PhD result. This is a very nice thesis. And yeah, they have the questionnaire. They also use this scale. It's very interesting. And this is the questions. And you can adapt these questions for your necessities. So it's very nice.
And the one thing I would do over that is to put directly context-related questions, almost like a quiz. So what I like is I ask them some stuff before the gameplay session. Then I ask very similar and most of the time the same stuff after they play the game and try to see if their answers change or how they change. And if it changes the other way, then essentially means that I'm doing something slightly wrong. So I try to adjust for that as well. This combined with that would be great, I think.
Yeah, and I made the same. I just prepare a pre-test for the students before the game, and after the game, I just make the same test, and I hope to obtain better answers. And in the most of the cases, it's like that. Yeah, and that's all. I don't know.
So
something else I can help.
So when I use it also for the evaluation of my game, of my trial game unit for Internet of Things testing, then I can also reference on it.
Yeah.
So I will also mention you because I think this is really the precedence here for maybe I need to update to modify some questions so that it matches my expectations, what I want to figure out of the experiences of the learner, but especially usability is one of the most important aspects.
Here is the step that I just mentioned before, that you need ethics approval, maybe. You need to consider it because in this moment I have that problem when I want to publish a paper, but they ask me this ethical approval. Maybe you can consider because it's an important step, and I have to write I just forget the name, the format. That all the participants explicitly say that they are they allows to use the information for the studies.
Okay.
Yeah, that's very important too.
They need to agree to use it.
Yeah.
It's agreement of the participants.
Yeah, that's.
Or you can make people voluntarily fill it out. You would have less data, but if you can't get the ethics committee approval, then you can make it voluntary with less data, but you should be able to use it then.
Yeah, in the most cases, all the people are volunteer, but in some journals, you need to have this approval on this format for all the process. That's something that that's my problem in this moment. I have to do all. Yeah, it's only for some journals, not for all.
Yes, I think you just touched on a very important point about approval of using the data and also about data privacy. In Europe, we have the big problem with the general data privacy laws that are very strict. And we have to be careful that we are not forcing our students to take part in a game and then using their data for research. I think what Barish said, that sometimes it's a better idea to not force everyone to use their data, but at least at the end you have their consent. Less
Yes.
data, but data that you can actually use.
Does the work, the consent, sorry. Yep.
Okay.
Yeah, thank you. Thank you.
You're welcome.
Any more interesting points or comments or suggestions? Or feedback for our 3 presenters today? No? Okay, then I'd like to thank you all for taking part, either late at night for the Europeans or probably in the middle of the day for our people from South America. And I hope that to see you all again tomorrow at the keynote, or at the latest maybe in the tutorial for gamification at 6 p.m. European Standard Time. What time is that in Brazil? Is that 12 hours time difference? No, can't be that much. Hawaii is 12 hours,
Yeah,
about
yeah.
8 hours time difference. Okay, then wish you all a good day, good night, and see you tomorrow. Thank you for your participation.
See you,
Bye.
bye-bye.
Bye,
Bye-bye.
thanks.
Bye-bye.
Bye.
Bye-bye.
Bye. Thanks.
Bye.
Brazil are 4 hours ahead.
4 hours, okay.
Bye.
Hawaii's 11 hours.
Oh my God. Bye. See you.
Bye.
Bye-bye. See you. Bye.